And it has found positive integers k and m such that m to the m times m to the k minus k is 2012. What we've actually got here is a product of two numbers that give 2012. So the first thing to do is to write 2012 as a product of prime factors. Now 4 goes into it because 4 goes into 12. You only have to check the last two digits to see if a number is divisible by 4. So we're going to get 503 times 4 is 2012. 503 looks pretty awkward. Actually turns out it's prime. This is the sort of thing that you might investigate before the competition. Otherwise, you're going to have to test divisibility rules up until the square root. So we can see that 2 and 3 don't go into it because 5 plus 3 is 8. So that's not divisible by 3. 5 clearly doesn't. 7, you'd have to start doing a little division for this. 7's into 503. Go, I'm kind of getting carried away here, but you'd have to kind of check until you get to the square root. You don't have to go beyond the square root, I must say, which is going to be more than 20, but it's going to be less than 25. So probably check all my primes up to 23. You might just go with it though and say it's going to be prime, and it ends up being so. So what that means is I've got 2 squared times 503 as a little product, and that is definitely tempting, isn't it, to say that m is 2, and then we just have 2 to the power of something else minus k that we want to equal 503. Well, let's write down our powers. We could write down our powers of 2, or you might know a few of them. Actually, it's worth learning, to be fair. 512 is 1, and that is very close to 503. So 512 is actually 2 to the 9. I always say to remember this one, 1024 is 2 to the 10. Very useful, because then you could just divide that by 2 to get your 512. So if we take 512 and we minus 9 from it, that will actually give 503, and this is then satisfied. What's the value of k? It's going to be 9.